So was the time less for the breakout room? Deepika, Akanksha? No, I think.
मैम 2 मिनट एक्स्ट्रा होता तो अच्छा होता.
अच्छा 2 मिनट. सुप्रिया अब नेक्स्ट टाइम 2 मिनट ज्यादा दे देना नेक्स्ट टाइम.
ओके मैम. नहीं मैम, हमारे लिए टाइम एनफ था.
अच्छा, सो नीलांजन के ब्रेकआउट रूम को ज्यादा टाइम चाहिए. ठीक है नीलांजन.
थैंक यू मैम.
So we'll now learn the paired t-test and Wilcoxon sign rank test. And in this, it is again, it is opposite to that independent sample. So in independent sample, what we learned that the samples should not be related. Means in each two independent group or the categories which you determine that should be unrelated to each other. Here in this case, we'll see what are the paired samples. So again, like all other sessions, we'll see the research questions, the assumptions, the commands, and then we'll summarize it. So if I want to measure a continuous variable on same individual, like systolic blood pressure in 2 seasons, like summer and winter, it will be a paired value because I am measuring the blood pressure in 2 seasons. Or I am measuring the blood pressure under 2 different conditions, like maybe before workout and after workout. Or in the same individual, I am measuring the blood pressure in 2 arms, like right arm and left arm, at 2 different sites, or through 2 different instruments, like automatic BP machine or manual BP machine. And I want to see the value. So for this, the appropriate statistical test will be the paired t-test. And these values are known as the paired values. So what are the various study design for which we can use this type of paired t-test? So first study design can be the participants are either the same individual tested at 2 different time points. Like we have seen that pre-post study or under different conditions or before after intervention. In all these cases, same set of participants are measured at 2 different time points, or participants are tested under 2 different conditions on the same dependent variable. Like for example, the same participants are tested at 2 different time points. I have measured the median intake of calorie in these 5 individuals before a modification of diet, before any intervention. Then I did 6 weeks dietary modification program and I have measured the median intake of calorie. And if I want to see the difference in pre and post, then it will be a paired t-test or a paired observation. Or I have given one intervention, which is the health drink one, and I'm measuring the kilometer run on the treadmill. Then again, after some time, I have given the other intervention to the same group, maybe the health drink 2, and I am measuring the kilometer run on the treadmill. And I want to see whether the health drink 1 is like mean, what is the mean difference in the kilometer run on the treadmill between the health drink 1 and health drink 2. So this is the same participants who are tested at 2 different two intervention on the same dependent variable. In this case also, this will be a paired observation. Or 2 body parts of the same individual. So like this is one, for the 4 kids are there. So in one arm, I have used a medicated cream, and in the other arm, I have used a non-medicated cream. And after a week, the doctor measured the redness on each arm. And I want to know if the medicated lotion is better than the non-medicated lotion. And the outcome variable is the diameter of redness. Again, like I said, right and left arm will be a paired observation. So what are the different research questions? If I want to know whether there is any change in scores in paired observation. So whether there is any mean difference in BMI value before and after a 6 weeks exercise program. What is the pain score measured on VAS before and after surgery? Is there any difference in marks obtained in pre-university and university examination of MBBS students? In all these cases, what have we seen? That there is a scale variable in each question, and I want to compare it before and after. So such study designs are also known as the pre-post study. An appropriate statistical test will be the paired sample t-test or a paired t-test. So there are some underlying assumptions. The first assumption is, again, like in case of an independent sample t-test, there's a one dependent variable which is measured in continuous scale. And the independent variable consists of two categorical related groups or matched pairs. And there should not be any significant outlier in the difference between the two related groups, and it should be normally distributed. So the null hypothesis states that the population mean difference between the paired value is equal to 0, and alternate hypothesis states that the population mean difference between the paired value is not equal to 0. Its non-parametric counterpart is the Wilcoxon sign rank test. Again, like we have seen with the independent sample test, like pain score, if my research question is like, does pain score on visual analog scale change after intervention in patients with arthritis knee, but I know that the variable of interest is not normally distributed, then I may go for the Wilcoxon sign rank test. So let's see its interpretation. How do we apply this? So in this case, this is the data set, and if I see the question, so first I have to check the distribution of difference of the following parameter. So in SPSS, those of you who have used the SPSS for paired t-test, there you have to create a separate variable for the difference between the first value and the second value. But in JAMOV, it automatically gives you the normality distribution of the difference of this parameter at baseline and at the time of outcome. So I have to compare these three values, SpO2, CRP, and creatinine at the baseline and at the time of outcome. So let's see how to run this. So this is the data set. In this, I will use this t-test, and this is the option of paired sample t-test. And here you have to enter the paired variables. So now you will have to select, like let's say first is the SpO2. So this is the first variable SpO2, and then I'll have to see the second SpO2. So this is the second SpO2. So I'll press shift and not shift, sorry, control. So this, I'll go up, control and press 1. So since I have selected 2 first, so it was wrongly entered. So what I'll do, I'll select this first, press control, and then press 2, and then move this, so that it's the 1 versus 2. The second variable was CRP. So maybe C-reactive protein, this one, and then the second one is I'll press control, this, and enter this. And third was the creatinine. So first I will select the creatinine 1. These are at the 2 different time points. And then creatinine 2. And enter this. So you have to be careful here that you have to select first observation first and then the second. And then you can check for this assumption. Say here, you don't have the other homogeneity and those assumptions because it's the same individual which you are testing at 2 different time points. So you can see that it is normally distributed because all the data points are here in this line. So that's why only you will go for the student t-test. You will see its value and the p-value. So all these 3 are significant. And then you can see the mean difference. You can see the effect size. You can see the descriptives. So in descriptive, it will tell you the mean difference. Here you can see the mean in two groups, like 94 and 95. This table will give you the difference, this mean difference. And this is the standard deviation and standard error. And this is the Cohen's d or the effect size. So you can see it is a very, effect size is not that high, it is very less, 0.1 up till 0.1, 0.2. And here you can see, so now what do you mean by this negative sign? Why there is a negative sign in the statistics? Why? Because you will see that the difference is also negative. That means here the SpO2 1, we do this minus this. So we expect the SpO2 to increase. So that's why the change is always like 1 minus 2. So if the second value is higher, it will be negative. That's why the value of this test statistics is also negative. And the other like effect size is also negative. So this is, I think, the same. If it is not normally distributed, like let's say we will see some other variable. Then in that case, let's say if it is SGOT. So you select SGOT and SGOT2. So then if you shift it here and you check for the assumptions, QQ plot, you will see that this is not normally distributed. So you will go for a Wilcoxon rather than this pair t-test. And again, like median, we have seen with the descriptive, you have to calculate the median. Median, so you will get it here, that IQR you have to do from the same, that part, descriptive, the way you have done for the independent sample t-test. And this is the value of Wilcoxon statistics with mean difference and the p-value. So this is very simple. No more, only one assumption and just one table. That's the pair t-test. So I'll again tell. This you have to just be a little. Okay, so I have to emphasize interpretation of values. So first I'll explain this because this is in front of me. So the first table tells like this is SGOT1 and this is SGOT2. So the Wilcoxon statistics is 8617. Its p-value, that means the difference. There is a mean difference of 15 in the SGOT level between the first and second measurement, which is significant. And effect size, like effect size here, it is 0.5. And like I said that in various tests, the effect size, choice of effect size is different. In chi-square, you have seen it was the Kramer V. In independent sample, you saw that it was Cohen's d. And here you will say it is rank by serial correlation. Through that, this gives the effect size. So value is 0.5. So 0.5 means it is a good effect size. So generally up till 0.1, we say like less. Up till 0.3, we say it is moderate. And like 0.5, we say it as a good effect size. So that's the interpretation of effect size. And this was for the first table.
Sorry
Yeah.
to interrupt. Ma'am, could you
Yeah,
please
please.
repeat the various effect size, what tests we use? Kramer V was for
I'll show. Let me show.
sure.
See, you click on this frequency, okay? Yesterday what we did. If you click this association, here if you go to the statistics, you will see this one. This is the effect size in case of a this two categorical variable. This phi Kramer V, this one, okay? If you go to the independent sample t-test, this one, and if I like move smoker here, and let's say systolic blood pressure or SpO2, anything. And then if you click on the effect size, you will see a Cohen's d. Can you see this Cohen's d?
Yes, ma'am.
If you go to the paired t-test, and like I have moved this, let's say I'll move this, okay, LDH. You have to select both together. So SBP, I'm just taking random, okay? SBP1 and SBP2. And I have shifted this. And then I've clicked on this effect size. Then you will see the Cohen's d. Okay. Which is same effect size. Basically, effect size is in the numerator. You take the difference between the mean. And in denominator, you take the standard error. So that's the formula for this Cohen's d, but it's the standardized difference. Basically, you are standardizing the difference in terms of the effect size. And for various tests, again, I said that measure of effect size and formula of effect size is different. It's not the same for all the tests. Like for ANOVA, it's the partial eta square or eta square. If you go for the ANOVA, you will see there is a eta square and partial eta square as a effect size. So the measurement of effect size, and in SPSS, I don't know, we have 22 version, but you have to calculate effect size. Every time you will not see the effect size, but here in Jamovi, you see the effect size. So negative effect size, the only sign that statistics I told, now the difference is negative here in case of a SpO2, because SpO2 is increasing. So that if the test statistics is negative, if you change this, it will be positive. Okay, I'll do that. Like if I move SBP2 first, SBP,
SpO2.
no, this one is also okay. If I select SBP2 first and then SBP1, and then you shift. So see, value will be same, but now the effect size is positive. So the sign only conveys that the second value is higher or lower. That means it is decreasing or increasing, the mean change. Otherwise, and it is directly related to the statistics. This T statistics is also conveying the same meaning to you, this one. If this is negative, that only means that it is, the second value is more. So that's why I did. I mean, I have entered here like this. Otherwise, it's better that you do first. And by this way, you can say that it will be universal rule for all the variables. Like first, and is there any difference? And with that, you can write the interpretation. Like the second, if the sign is negative, you will write that the second value was less or more, or what you are expecting. Is the variable of interest, is the higher value is desirable or a lower value is desirable? So in CRP, a lower value is desirable, but in SpO2, a higher value is desirable. Hemoglobin, higher value is desirable, because definitely after intervention, you will expect that hemoglobin to rise. So that's the only difference, I mean, implications or the interpretation of sign. And then about the other, like if descriptive, if you click this, okay, I don't have any. So like SpO2, if I want to show this SpO2 1 and SpO2 2, so this is the descriptive, means it will give you the mean of both the, like, what is the value of SpO2 in the before and after 1 and 2 with the median and standard deviation and standard error. So like one of you have asked that you should report what, SD or SE. So it is up to you. So you can see here SD is 4.71, but SE is very small, 0.35. So SE is in the population and SD is of a sample. Okay. So Wilcoxon is again the same. if it is not normally distributed, so because if you see the QQ plot, this SpO2, you will see that this is normally distributed. But for other variable, like I have shown with the LDH and SgO2, since this difference, this normality testing, this QQ plot was not normally distributed, that means these data points are not across the diagonal line. That's why we can say that this is not normally distributed, and then you will go for this Wilcoxon rank. So here there is no testing of homogeneity. Because why there is no testing? Because it's the same sample which you are testing twice. So there is no point of different variance because it's the same sample. Okay? Any other question or any other like interpretation or anything you want me to repeat? Till now, no one has asked this missing value, exclude cases analysis by analysis and exclude cases list by. I hope all of you know this because those of you who are using this SPSS also this option is there.
Just the effect size का interpretation एक बार बता दो.
इफेक्ट साइज में होता है दैट आप उसका क्लिनिकल इम्प्लीकेशंस होता है उसका. रुको एक मिनट, मैंने कुछ स्लाइड खोल के रखी हुई थी एक. ये एग्जांपल देखो, ठीक है. अ रिसर्चर, अच्छा ओके, मिसिंग केस 15. तो फिर क्या करूं, पहले मैं मिसिंग बताऊं या पहले ये बता दूं 15? व्हाट शुड आई टेल दिस? शुड आई टेल दिस फर्स्ट? Since I have displayed the slide, let me explain this first. I'll go to the missing value. So a researcher wished to study the effect of a new drug on blood pressure control with respect to standard drug. And they got the following result. Mean difference in SBP in the standard drug versus new drug was 15 millimeter. Okay? And the mean difference in diastolic blood pressure in standard drug versus new drug is 5 millimeter. So can you tell that the new drug has got more effect on SBP as compared to DBP? Can we say that?
Yes.
Yes, but if you see the effect size of this is less, 0.33. And effect size of 5 millimeter is 0.42. So which has got a larger effect size? This one? So in evidence-based medicine, or whenever I have to take decision, I'll convey that it will have more clinical implications on this DBP as compared to this SBP. Although the mean reduction is more in SBP, but the effect size is more in case of a DBP. So effect size is only, I can say that in case of a judgment, like you will say that it will be more effective. Effective, should I say that or not? Actually, basically, we standardize this change because if you want to compare the two, so how will you compare? That's why that difference, we standardize it with the standard error. And that's how, after standardization, we say that now you can compare the two. So larger effect size will be like more weightage in the clinical decision making. Here you can see that the unit is same, but if you are having any other maybe unit where you cannot compare the two because if the units are different, so with effect size, it actually standardizes. Okay. And then comes the which I was asking, this exclude case analysis by analysis and exclude cases list wise. What do you mean by this? Can anyone explain this? This default option is always clicked. So when you click this exclude case analysis by analysis, that means it will only delete that particular variable which is missing. If you click this exclude case list wise, then what will happen? That the whole row will be deleted. I think I can show this with few examples. I'll go to the data, let's say variable, no data. So if I delete one SpO2, SpO2 1. So let's say I have deleted this data, 99. So if I go to analysis by analysis, and I have entered here, so it is 179. Initially it was coming 180. Now if I do this exclude cases list wise, again it is 179. Why? Because it is for SpO2. But if I delete any other variable, let's say I'll go to the data and I will delete this cortisol also. Cortisol, any other data, let's say this second value. Cortisol, delete. And if I'm using this, then it will have no effect. But if I exclude this list wise, then you will see it will be, why it is not taking 178? It is paired, that's why. No, ideally it should take before, after.
Oh. It's not working. No, it is only for SpO2 here. Paired test we have done only for one. We have to do it for both, I think.
No, but they should have taken.
सेम दो नंबर से लाइए ना SpO2 का कहाँ हटाया इधर सेम
एक-
बटा सेम
एक-
से डिलीट किया है क्या
Just a sec. Maybe that
Maybe आपने same
just a sec. What mistake I have done? No, I have deleted one from second row.
But cortisol we have deleted, no? So we have to do cortisol ka paired t-test.
No. I'll tell you what I have done. SpO2 I have deleted first.
तो दो डिलीट होना चाहिए
हाँ, दो
एक और डिलीट की रैंडम
no, let's say
इसको इंटरफेस में करना चेक करना होगा
no, with some other thing we can see. Ideally it should have been like 176 because it will delete all that.
केस लिस्ट वाइज
It is not changing in this case. It is same.
Okay, we have to check it.
I'll check this probably why it is not working. Ideally it works.
We can even break out of it.
But the meaning is same, that it deletes the whole row. Let me check. In the meantime, you people can practice in the breakout room. I'll tell you once you are back into the main room. Where is the bug and why it is not taking? Okay. Let me see it. Supriya, can you open the breakout room for this?
Yes, ma'am. I'm opening the breakout room.
And give 2 minutes extra to Nilanjan.
Okay, ma'am.
Thank you, ma'am.
Ma'am,
Yes?
so I have one question.
Yes, please.
So I just put it in chat box.
Okay, ma'am, in your previous example, your previous SBP or DBP, not continuous. This is the question, Bharat.
Yes,
Any problem there? Means SBP, DBP in case of a pair t-test you are
yes,
talking.
yes.
Let me check.
Continuous.
So it is a continuous variable, SBP and DBP. No. Why it is not continuous? It is a continuous variable. See the data. This is SBP. This is continuous. 120, 110, continuous. Okay. There's no problem. It is a continuous data.
Break out.
Supriya?